Are you captivated by the stunning beauty of our solar system? In 2021, Juno embarked on an extended mission beyond its original plan of 37 orbits to include flybys of Jupiter's icy inner moons, Ganymede, Europa, and eventually Io. It's been over 20 years since Galileo's visit to these moons, and through studying the changes in them, NASA aims to uncover what might be happening beneath their icy exteriors. And without revealing too much too soon, that seems to be quite a lot. Thanks to the powerful cameras on board, JunoCam and its Stellar Reference Unit navigation camera, Juno is capturing some of the finest images we've ever seen of these icy moons. With the long-running mission approaching its conclusion, NASA planning to decommission the probe in September 2025. It's a good moment to ask, what has Juno actually seen? Join me today as we explore the breathtaking highlights of Juno's extended mission and uncover the surprising discoveries already reshaping our understanding of the Jovian system. Let's begin with a small clip from about 14 years ago. Juno launched from Cape Canaveral, Florida in August 2011. After a journey lasting 5 years and covering 2.8 billion kilometers, the spacecraft started orbiting Jupiter on July 5, 2016. Following the completion of most primary objectives, NASA extended Juno's mission, shifting focus towards some of Jupiter's biggest moons. By 2025, the total number of added orbits, perijoves, will reach 42. After which NASA will deorbit the spacecraft by burning it up in Jupiter's atmosphere to prevent potential contamination of those moons. This procedure aligns with NASA's planetary protection protocols, but it's especially critical in Juno's case. Scientists have long wondered whether life could exist on Jupiter's inner moons, and NASA is eager to avoid contaminating any future discoveries there. On June 7, 2021, Juno performed close flybys of Ganymede, using a gravity assist to bring its orbital period down from 53 days to 43 days. It had previously flown by Ganymede from a distance of 97,000 kilometers in 2019, but this time it swooped to within just 1,000 kilometers of the moon's surface. In this image captured by JunoCam, nearly half of Ganymede's surface appears in stunning detail. Observe how the icy surface is scattered with craters, light and dark patches, and elongated streaks. The darker regions indicate older terrain, heavily cratered, while the lighter zones are comparatively younger and less pockmarked. But what about these long streaks? Based on earlier data, we know Ganymede has at least one vast, salty subsurface ocean beneath its icy crust. Some speculate it could be habitable. Scientists believe these elongated features might be faults caused by tectonic activity, possibly driven by heat from the moon's iron-nickel core, though research is ongoing. This next image, taken during the same flyby, provides a closer look at Ganymede's Trost crater. It appears so bright because it's covered in ice. Again, you can see the long streaks and craters, some overlapping. I've seen many Ganymede images before, but I'm truly impressed by the level of detail Juno captured in such faint light. One of the most surprising findings of the mission, however, didn't come directly from Juno, but from the Hubble Space Telescope. Yes, that Hubble. Let me explain. NASA tasked Hubble with monitoring Ganymede's ultraviolet signals to support Juno's exploration. Ganymede has a very thin atmosphere, and NASA's goal was to detect traces of oxygen, something they've long suspected. Most expected to find abundant oxygen based on previous ultraviolet emission studies, but instead, they found surprisingly little oxygen in Ganymede's atmosphere. What they did discover was a significant amount of water vapor. This led to a major revision of our atmospheric models for Ganymede and suggests that water vapor might also be present in other icy bodies throughout the solar system. After Ganymede, Juno flew past Europa on September 29, 2022, gaining a gravity assist that shortened its orbit to 38 days. The shadows cast by the ridges, craters, and troughs give the surface a striking three-dimensional appearance. You might think Europa, like Ganymede, conceals a vast ocean beneath its ice, but recent findings suggest there's more complexity than that simple model indicates. What do I mean? Europa's icy shell is more than 10 kilometers thick. Imagine the pressure needed to penetrate that much ice. But a new paper from the American Astronomical Society offers a different explanation. It proposes that Europa's cryovolcanic activity might involve brine reservoirs trapped within its icy crust. This suggests that, above the subsurface ocean, there could be lakes of high salinity brine slushing around, expanding the ice like a balloon and sometimes bursting through. It's an intriguing theory, but confirming it will likely require the European Space Agency's upcoming CLIPPER mission, expected to arrive at Europa around 2030. I know that's 8 years away, but it's never too early to mark your calendar. Returning our focus to Jupiter, While Juno was investigating Ganymede and Europa, it also solved a mystery that's been around for over 40 years. Back in 1979, when Voyager first visited Jupiter, the probes detected mysterious flashes in Jupiter's atmosphere. Most scientists thought these were lightning bolts, like those on Earth, implying water in all its forms, solid, liquid, and gas. Given Jupiter's atmosphere, it was believed these storms occurred at least 45 kilometers below the cloud tops. But Juno proved that theory wrong, revealing a far stranger reality. Its Stellar Reference Unit camera observed nighttime flashes at much higher altitudes than expected. Because temperatures there plunge below -88 degrees Celsius, scientists deduced these storms involve ammonia water clouds, something we don't see on Earth. In these violent thunderstorms, ammonia acts as an antifreeze, creating a liquid solution of 2 parts water to 1 part ammonia that remains liquid despite the extreme cold. These storms produce powerful lightning and drop hail made of water ammonia slush, what scientists are calling mushballs. Jupiter continues to surprise us. Its mysteries grow deeper with every discovery. So, those are some of the most captivating highlights from Juno's trailblazing mission since our last update. Juno has far exceeded my expectations at every turn, and based on Ganymede and Europa, our understanding of Io is about to become even more fascinating. The images Juno has returned are incredibly crisp and breathtaking. If you're like me, one of the things you love about space is the incredible beauty of the vistas out there. Thanks for watching. Please like and subscribe.